This demonstration of a small section of an automotive body in white highlights some of the improvements in Workbench Mechanical in 16.0 for shell structures. This example has several parts connected through spot welds. The spot welds were constructed earlier in Design Modeler. In 16.0, the shell mesher generates the mesh using parallel part-by-part meshing and tries to obtain more orthogonal mesh on the parts and around the spot welds, leading to a higher quality mesh and better simulation results. Also new in 16 is the ability to color the mesh by element quality and being able to move nodes interactively to improve the mesh. In general, the mesher tries to get a high quality mesh automatically, but in some locations the trade-off between which features to capture and mesh quality can overconstrain the mesher. In these areas, the mesher will often err on the side of capturing the features. At times, a user will have certain quality metrics they want to achieve and want to improve the mesh so that no elements are below that criterion. This can be done by using custom legends and just fixing up elements that are displayed in red and/or yellow. Okay, so the mesh has been generated and we can inspect the mesh. We see that the mesh is of pretty good quality while capturing important details. There are many ways to adjust the mesher to capture less details, but this will not be covered in this demonstration. The legend is interactive and a user can quickly adjust it to create a custom legend with discrete bands relating to defined quality metrics. This custom legend can be saved and reused in other projects. Once defined, the node move operation can then be used with the min location finder to find and fix elements that are below the desired quality metrics or those elements marked as red. As the mesh is improved, the min value updates. A few tips when using the node move operation. First, elements with bad quality are that way for a reason, generally because they have 3 or 4 nodes locked to the geometry. The F4 hotkey is required to move nodes off of those constraints. Number 2, use undo if you accidentally move a node in an undesired fashion. The worksheet will tell you all the node move operations you have performed, but keep in mind that those operations are not persistent. Number 3, keep in mind that some nodes are constrained by spot welds. The spot welds can be moved, but it could change the constraint equations, so it is recommended to try to avoid doing this. I hope you will find this to be a tool that is not needed very often, but provides a lot of flexibility when needed. Thank you.